Okay, so one of the important techniques that we need to look at is how do we factor quadratic functions? That is, how do we take a quadratic function in this form, x squared plus 3x plus 2, and break it down into the two linear expressions that, when multiplied together, create our quadratic function. In this case, the factors are x plus 2 and x plus 1. And the ability to do this is important for a number of reasons, two of which are we could then set this expression equal to 0, so x plus 2 equals 0, solving x equals negative 2. And this is a real root of our quadratic function. Likewise, x plus 1 equals 0, x equals negative 1 is our second real root of our quadratic function. So that's one important reason why we need to understand how to factor quadratic functions. The other reason is we can then use this pair of factors and possibly simplify a rational function involving this quadratic equation. So how do we do this? We're going to look at how do we factor by grouping. And we saw grouping with our cubic functions. But what we're going to look at today is how do we factor a quadratic, where it's 5x squared plus 11x plus 2. With a cubic, we had four expressions, or four terms. And so it was easy to group one pair of terms and a second pair of terms. Here we have three terms because our quadratic is a trinomial. So we need to create a fourth term by splitting this 11x into two pieces. And the way we're going to do that is we're going to remember that our quadratic function is in the form ax squared plus bx plus c, where the a, the b, and the c are our coefficients. And our first step to factoring by grouping is to find the product of a, c. A and c. In this case, 5 times 2, which equals 10. So now that we have the product of AC, we're going to look at our B value, in this case the 11, and we're going to find factors of this 10 that add up to 11. And if we look at our factors of 10, we can break it down into 1 and 10 and 2 and 5. And looking at this, 2 and 5 add up to 7, so that's not going to work. 1 and 10 add up to 11, so these are the factors we're going to use. So now we're going to rewrite our function, 5x squared plus 10x plus x plus 2. This is the exact same function as this, because 10x plus 1x equals 11x. But now we have four terms, and we can factor by grouping the first two terms and the last two terms. And it does not matter if you put the 10x first or you put the x first. Either way, it'll still factor the way we need it to factor. So now that we have our 5x squared plus 10x, we want to look at what's the greatest common factor that we could pull out of this. And looking at it, we can pull out a 5x. And that's going to leave us with x plus 2 inside. And then x plus 2, we cannot factor anything out. There's no greatest common factor there. So we're just going to leave it as x plus 2. Now, one thing to remember, in front of this x plus 2, there's an implicit 1. There's always that 1 value there. Now, if we look at this, we have this 5x times x plus 2. We have this factor x plus 2. And then we have this 1 times x plus 2. We have this expression x plus 2 here as well. So we can factor out this x plus 2 and bring it to the outside, x plus 2. And what we have left on the inside is our 5x plus 1. And now our quadratic 5x squared plus 11x plus 2 is factored into x plus 2 and 5x plus 1. And if we needed to, we could then solve for our zeros. X plus 2 equals 0, so x equals negative 2, and 5x plus 1 equals 0, so 5x equals negative 1, x equals negative 1/5. So there's our two real zeros for this quadratic. Additionally, if this quadratic were part of a rational function, then we could look at for common factors in the other piece of the rational function to see if we could cancel one of these out in order to simplify. All right, so factoring by grouping, we start out with our quadratic function that we want to factor. We take the product of a and c, so the coefficient in front of the x squared and the constant. In this case, that was 10, 5 times 2. And then we look at the b value, 11, and we check to see which factors of our product, AC, our 10, add up to our 11, in this case, the 1 and the 10. So we broke up our 11x into 10x and x, which allowed us to then factor by grouping this first two and second two terms. Factored out our greatest common factor, no greatest common factor in this case. And then we factored out this common expression, this x plus 2, leaving behind 5x plus 1. So we have our two linear factors for our quadratic. And then if we needed to, we could solve for our zeros. Otherwise, if we were dealing with a rational function, we could then look to see if there were common terms in the other half of the rational function, which will allow us to cancel and simplify.